Welcome everybody to Philosophy of Science. I'm your host, Father Deacon Dr. Ananias. And just to let the audience know, we've got, let's see, 18 viewers. Let's get some more people on in here. I had a little episode this week, last week. And what happened is I always record my lectures at the university. That's so that I have them saved for the students to review, and also I do have some independent study students that rely on those. And looks like last week all of my recordings had no audio. That something happened with the audio video equipment, and on the Zoom it went to a default mic, and so there was no audio. So I'm going to redo the lectures. Lord have mercy. But it's great. We'll be using this book right here that I know everybody in their home growing up has a copy of this. No, what I'll do is I have a free PDF copy that we'll just kind of go through, and we'll work through this as we always do in class. I'll also make some reference to the Curtin-Cover book, The Philosophy of Science. So let's see, are you ready for Philosophy of Science? We're going to go over the topic and question of why should nature obey laws. This is a great chapter in Chalmers' book here, and it's just a great topic too as we approach the end of the semester, kind of recapping everything that we've learned and going into some of these fundamental questions. Alrighty, let's just look here. So here you'll see the PDF right there. This is chapter, like I said, chapter 14. Why should the world obey laws? But before we get into that, I wanted to read you something from, let's see if I remember the page number. So there's a whole section, Curtin-Cover, too, on laws of nature. And in here, there's a famous article by A.J. Ayer, and which he's talking about laws of nature. And interesting enough, he references Hobbes, the Leviathan, in which there's 15 laws of nature. But I find, when Hobbes is talking about civil laws and laws of nature and these different things, he makes a really interesting comment here, and I want to read it to you. His laws of nature are like civil laws, except that they are not the commands of any civil authority. And this is A.J. Ayer speaking. In one place, he, Hobbes, speaks of them as dictates of reason and adds that men improperly call them by the name of law. So he's saying they're actually improper to call that. Then A.J. Ayer quotes Hobbes and saying why that he believes it's improper to call them by the name law. Quote, "For they but the conclusions or theorems concerning what conduceth to the conservation and defense of themselves, whereas law," again this is Hobbes speaking, "properly is the word of him that hath by right hath command over others." But yet, he continues, if you consider the same theorems as delivered in the word of God, that by right commandeth all things, then they are properly called laws. Now, that is really interesting, because what we're going to go through here is a whole conversation about how we're going to define laws of nature. And so I open up this lecture with Hobbes' consideration that really we speak loosely and properly, at best, in a derivative sense, of law that is most properly called law in light of God. The only one who has the sovereign right, has the sovereignty and the right so that he can commandeth over all things and put everything in its proper place and make it law-like. I find that really fascinating. Now, A.J. Ayer does not, and he just brushes it off because he says that, well, this is just a theological conversation, and well, you would have to prove the existence of God, and not everybody believes in God, and then just sweeps it right under the rug. But as we often see, that these questions always go back to the more fundamental theological questions. It always goes back to, does God exist? And every time I find that this is actually the case, that philosophers will just ignore it. I don't want to go there. I don't want to talk about them. Not everybody believes in God. All right. So we'll get into that. But I just thought I'd open with that and then tell you that A.J. Ayer doesn't deal with it all. How's everybody doing? We've got 28 viewers. Let's get some more people in here. Feel free. I'll be answering questions, so feel free to throw in your super chats there. You'll see that I have it in the comments section. Amptown1 donates $5. Can't watch live, but we'll be watching later. Thank you for all you do. Thank you, Amptown. So feel free to, if you have questions as we go through, or after the lecture, please send in your super chats. And then also, if you haven't subscribed, please do. The algorithms are not only burying my stuff, but YouTube's actually taking away subscribers, so I'm just, what am I going to do? Okay, let's move on. And I'm going to pop up and It's interesting that in many senses, lecture for philosophy of science, we use the textbook and we kind of go through in a very kind of Socratic way, like we would in a grad school class, where we go through the actual text and we pause and kind of discuss these things. And that's what we'll do tonight, and then I'll put this up for my philosophy of science class, since what we did record had no audio. It's unfortunate because a lot of you students in that class had wonderful things to say, great questions, a great conversation, a great class. This is often the case in the philosophy of science class, but it is unfortunate that we've lost all your input as far as being recorded. So for that, I apologize. And let's move to the text and work through these questions. Why should nature obey laws? And in order to answer that question, we're going to have to figure out, well, what say you? What do you say that laws actually are? Okay, let's begin. So you'll see here that we have Chalmers is going into, well, first a kind of summary that primarily through the course we have been concerned with the epistemological questions about knowledge and how that relates to science and all the various complications with that, people's support of that and the critiques of it, and seeing where it's failed. That's been from chapters 1 through 13, basically, the epistemological questions. We weren't really, after reviewing everything and reading, we were left in a position that it doesn't seem that we can, thus far, get to a position of actual knowledge in science because of the various historical issues and then also the philosophical issues that were addressed. I could re-summarize real quick that, and if you remember when we went into new experimentalism, we discussed this, and I'll just read it real quick just for the audience too, that because it gives a great summary of what we've covered thus far. So in the introduction of chapter 13 on the new experimentalism, it basically gives an entire summary of what we've covered thus far, and so I'll read it. If we regard the Bayesian account of scientific inference as a failure, so chapter 12 we did the Bayesian theorem, right? And there was hopes that that would get us out of a lot of the problems, the epistemic problems, and then as we always find out, and it doesn't, it fails. It fails to do anything for us. And so he goes on, he says, we still have not provided much by way of some characterization of what is it that's distinctive about scientific knowledge, if there is any such thing, or maybe say science itself. And that's been a theme throughout our course as well. Karl Popper posed problems for positivism. So notice how this course has gone. Each person promotes a particular theory that's supposed to solve the previous problem. And then you get the next person, philosopher, comes along and is like, no, it doesn't work. It's got problems. Now, that's just a negative criticism, and then oftentimes they'll put forth a positive case, and then the next person comes along and is like, and it doesn't work. And so you're seeing this here in the kind of summary of what we've gone over thus far. Logical positivism was, no pun intended, posited, and Popper comes around and shows problems particularly with inductivism. So we talked about logical positivism and inductivism. Then Karl Popper comes, not to mention the stuff that we reviewed by Hume. And Popper stresses theory-dependence observations. So the logical positivists, the positivists, and the radical empiricists were destroyed by that. They couldn't get out of that. That, wait a minute, there isn't just observation. There aren't these kind of naive, just observational statements that can be empirically verified. Why? Because everything's theory dependence. The theory dependence of observation. So this is what he's saying right there. And the extent to which theories always transcend and can never be derived from the evidence. And as we'd stated last class, we know that also is reiterated by the Quine-Duhem underdetermination of data thesis. So it goes on to say Popper's account of science was based on the idea that the best theories are those that survive the severest tests. However, his account was unable to give us clear guidance as to, when was a theory, rather than some element of the background knowledge should be held responsible for a failed test. So again, look, it looks like we're out of the problems. Yeah, that sounds great, Popper. You have this falsificationism, and so the better, science is that survives those severe tests. What's the problem? It doesn't give me any clear guidance when something does go wrong, whether that it was the theory that was wrong, or rather some element of the background knowledge, or the experiment that should be held responsible for the failed test. And so what that shows us is, sorry, Popper, you're not able to say anything sufficiently positive about theories that happen to have survived tests. Also, the thing that we saw, too, is that if we really did apply Popper's falsificationism, none of our good scientific theories would be here. Everything would have been out the door. So not only does it not provide us a heuristic, it doesn't, and neither does it provide us indication of where, when things fail, where that happens. So who comes along but Lakatos? Lakatos introduced and thinks he can get out of the problem by introducing research programs. We saw them returned or rejected according to the conventional decisions. Decisions, for example, to blame auxiliary assumptions rather than what he called the hardcore principles of the research program for apparent falsifications. So that means you could have your theory, because it's the hardcore of the research program, survive, and then you have supposedly had a way of seeing where things went wrong. Well, that's all the auxiliary assumptions that, things like epicycles that we could change and throw out. However, he was unable to give grounds for those decisions. In any case, they were too weak to specify when it was time to abandon a research program in favor of another. Because that's the thing. You're going to have enough problems. When is enough problems so that you abandon it and you move to an entirely different paradigm, as Kuhn points out? Well, Lakatos doesn't say that. It doesn't give us any sort of indication of how to figure that out. Speaks here, Kuhn introduced paradigms rather than research programs, thus introduced a degree of paradigm dependence in science that was far more reaching than Popper's theory, so much so that Kuhn was even worse off than Lakatos. Why? Because it ends up being completely reduced to sociological questions and can't give any clear answer to the question in which a paradigm could be said to be an improvement on the one that it replaced. Then, of course, we visited Feyerabend, who can be seen as taking the theory dependence movement to its extreme, giving up on the idea of special methods and standard for science altogether. Remember his anarchism? And joins Kuhn in the portrayal of the rival theories are incommensurate. But then you basically have to say that there's nothing special. What did he say? There's nothing more special about science than anything else, and should be studied along with mythologies from all the other mythologies from primitive societies. Okay, so the Bayesians can also be seen as taking part of what I'm calling theory dependence tradition. But for them, the background theoretical assumptions that form the judgments about merits of scientific theories are brought in way by prior probabilities, and then we saw all the problems with that. Okay. And then we got to like Deborah Mayo's new experimentalism that had this severity, but test of severity, if you remember that. But that doesn't lead us in much of a better situation. Okay, I just summarized the entire course thus far. Everybody good on that? I know it's a lot to go over, but it has been a great adventure. And so now that we've gone, remember, all of that's the epistemological kind of concerns about science. Just to say real quick that Deborah Mayo's characterization of severity, as she put it, remember she has this test for severity, is, well, that's just, you're able to, basically you're going to ask yourself whether the confirmations within science would have been likely to occur if the theory was false. Okay, there I summarized. There's Deborah Mayo, and who is the most extreme version of new experimentalism. And that ends our consideration, the epistemological considerations about science. And so now we're going to move into ontological questions. Ontological having to do about the existence, the status of existence of the things that science talks about, the entities, the theory itself. Are there really these kinds of things out there in the world that science talks about? So you see the transition that we're making. What kinds of entities are assumed, are shown to exist in modern science? Because remember, ancient science, we have four elements. You have humors, these different things that we no longer believe exist, right? So we need to focus on that question itself. And so part of this is about laws. Do laws exist? Well, before I can answer that question, I need to know what a law is. And by the way, the next chapter is really interesting, and that's following along the lines, too, of the second part of this book, of the ontological questions. Here we have a thing about realism and anti-realism. And if you remember that chart that I had up, we'll probably bring that back up, where it's the naive realists on the left-hand side going all the way over to the anti-realists. So, but that's the next chapter. So let's focus on right now laws. Because we tend to think that laws exist. I guess we've taken for granted that these things exist, but we haven't asked these questions. Such as things as laws which govern the behavior of the world, and which it is the business, obviously, of science to discover what? Laws. So that's what we're doing in this chapter. So far, so good. Let's see how you guys are doing in the chat. I'm losing anybody. It's the law. Very good. Anybody else have any super chats to ask questions? If not, I shall move on. And I'll pop up the textbook so that you can follow along. Just like we do in class, too. Okay. Oops, I went in the wrong chapter. So as you see here, he's talking about the idea that the world is governed by laws, that it is the business science. Okay, I already talked about that. Now, all of you just assumed that. Well, yeah, of course. And what does the author state? This question of what the idea amounts to is far from being unproblematic. Surprise, surprise. Fundamental problem was highlighted by Boyle in the 17th century. And this is why I actually started with the quote from Hobbes. Because look at what he points out here. The notion of law originates in the social sphere, where it makes straightforward sense. So the reason why I took you to Hobbes to begin with is that he's defining it within the social sphere, but he's really saying that's derivative. We can only say that in the proper sense in terms of one who has, remember, the sovereign, the absolute sovereign, has command over everything, would be God. So in fact, the social traces back to the divine in Hobbes' view. Society's laws are obeyed or not obeyed by individuals who can comprehend them. So what he's doing here is he's basically saying it makes sense the way that we talk about laws in society. And we use the same word, and we've got to be careful not having a word concept fallacy here and equivocation on law, because once we start to think about, we can't apply those attributes of law that we properly get within society to nature. Why? Because once laws are understood in this natural way, how can it be said that material systems and obey laws? We can break them. We can violate them. There's consequences. Does nature do that? Well, he says, for they can hardly be said to be in a position to comprehend the laws. That's a good point, too. What does nature have laws? I know what it means for me to say in society there's laws because I can comprehend it. I can break it. It's meant to obey. But how does that apply in nature? Fundamental law as it applies in science is supposed to be exceptionless. So there's no correlate to an individual's violating social law and taking the consequences. Isn't this great? So what makes it matter? What makes matter conform to laws? Great question. So Boyle has something similar to what eventually, what Hobbes had said as well. God makes matter behave in accordance with laws. He's ordained. But just like A.J. Ayer, what does he say? That leaves a lot to be desired from a modern point of view. So let's just sweep it under the bus. And if you remember last class, we actually talked about this. I'm going to hold off on that question for a little bit because we're going to come right back to it. But ultimately, I think Boyle and Hobbes are right. You're not going to actually be able to answer this without going to God. Because what we're going to see is what we saw through this entire course. Every person comes up with a proposed solution that fails to give an account for. And so that's what we're going to do here. We'll bracket the God question. Note that Boyle has the idea that God makes matter behave in that way. And let's just see if the secularists can do any better. And the first thing is that an empiricist or a secularist, it might want to actually say that law is regularities. And so let's go through and explore that and do an analysis on, does that work? Would that fulfill our needs in this way so that it'd be sufficiently robust that we could say this is what a law is in science? Any questions so far? Everybody following? You guys aren't even talking science, you're talking about ribeyes and salads. Alright, I'm ignoring your nonsense. In this room, we believe in science. In this house, we believe in science. All right. Although we haven't been able to define the entire course, like what exactly is uniquely science versus non-science. And what have we learned from the authors? Well, when there's a problem, just sweep it under the rug. Just ignore it. Okay. Laws as regularities. Okay, buddy. What makes matter behave in accordance with laws? So one common response to the question is just simply to deny the legitimacy. Now, you might know this man here that we're real familiar with. This man-child. David Hume. So, how would David Hume answer this question? What makes matter behave in accordance with laws? Well, he's going to say there's nothing law-like. Just deny it. Deny the legitimacy of the question. Which is what I always do with people, right? If I don't like the question, I deny your legitimacy of your question. I'm offended that you even framed it that way. So says David Hume. It's wrong, says David Hume, to think that law-like behavior is caused by anything. So basically what he's saying is to ask the question what makes matter behave in accordance with the laws is probably assumed the notion of causality in there. But it's wrong to think that there's causality, that anything's caused, right? That's why he says here, the whole idea of causation in nature is brought into question. And of course, we know the billiard ball example. Two billiard balls walk into a bar. No, two billiard balls collide. We can observe their motions immediately before and immediately after the collision. You want me to highlight this real quick so you know where I'm reading? Yeah. Okay. Two billiard balls collide. We can observe their motions immediately before and immediately after. So we have temporal sequence. And we may be able to discern a regular way. So here we have regularity, which is the title of the section. We may even have a way of determining a regular way in which the speeds after the impact are connected to the speeds before the impact. But what we never see is something in addition to this, which can be identified as a cause, with the causal effect of one ball on the other. So from this point of view, causation is nothing more than regular connection. It's correlation. As you always say, correlation is not causation, as we always hear. Laws take the form of events of type A are inevitably, excuse me, let me just highlight that. Events of type A are inevitably accompanied or followed by events of type B. That's the inevitably, we'll have to figure out what that means. But for example, when we look at the law of gravity from the Galilean point of view, or I should say the law of fall, because we don't get until Newton really a law of gravity. He states, whenever a heavy object is released under the Earth's surface, it falls to the ground with a uniform acceleration. So this is the so-called regularity view of laws. So that all of that is to say that that's a way to respond to the original question up here, what makes matter behave in accordance with the laws? If your response was just to deny the legitimacy, you would say nothing makes. To make something is a cause. And what did David Hume show? You can't ever get to causality. Nothing makes matter behave in accordance with the laws because laws are nothing other than de facto regularities between events. Dang. Just restored your worldview, bruh. What do you think about that? Oh, here, this one's good. We'll go further. So, where do we conclude right here? They're just regularities, okay? So I built up the position right there. Now let's tear it down. The objection to laws as regularities. Well, sorry, buddy, but that doesn't distinguish between accidental and law-like regularities. So you see what's going on here? Do you finally see? We started with the question, why should nature obey laws? And you're like, well, what's a law? Then the first thing was, the only way it seems that I can properly say that is within the social sphere that's derived from ultimately the divine. It's God that sets forth. He pushes that aside and then says, well, how are we going to explain it then? Oh, regularities. Why regularities? Because Hume showed us we can't have causation. Okay, so you're about ready to say that, okay, I guess it's regularities between two events. The objection then is, well, that doesn't distinguish between accidental and law-like regularities. And Karl Popper gives us an excellent example of that. So let's look at what Karl Popper says. No moa live beyond 50 years is supposedly the example. Well, it may well be the case that no moa, as a species now is extinct, ever lived beyond 50 years. But some might well have done so. Had the environmental conditions been more favorable. And for this reason, we're inclined to discount the generalization as a law of nature. But it qualifies as a law on the ground that it is an exceptionalist regularity. It may well be the case that whenever the factory hooter sounds at the end of the working day in Manchester, the workers down tools in London. So remember, what he's trying to address is this idea of regularity, exceptionalist regularity. That doesn't distinguish whether it's law-like or accidental, is what. Because I can think of these counterexamples. Moa and the Hooter Sounds in Manchester. And wow, look, without exception, the workers down tools in London. But even if there's no exceptions, do you think that qualifies as a law of nature? Are you kidding me? And examples of this abound. Maybe you can think of some. Another difficulty with regularity, the regularity view. Yes, this is great. It fails to identify the direction of causal dependency. So suppose we could get over the Humean problem and we still have the laws as regularities in terms of causes. Which way? Which way, young man? Which way, young cause? Which way do you go? Because look, here's going to be some examples in science. There's supposed to be a regular connection between instances of smoking and lung cancer. Because, so notice in here, the being of it, cause. Smoking causes lung cancer, not the reverse. Dang you. Dang you, lung cancer, always making me want to smoke. And that's why, as far as medicine, science, you can decrease, or at least hope, the occurrence of cancer by eliminating smoking. This is hilarious. But you can't hope to combat smoking by finding a cure for cancer. You see what the problem is? Okay, so let's say I had regularities, exceptionalist regularities. I need in science a causal dependency, and it's not going to do that. Because we're operating this way in science. I just gave you 2 examples. And think about how bizarre it was if I didn't. It was like, well, there is no direction I can go. Then I'd be trying to get people to stop smoking by curing cancer. Do you see the issue there? Great counterexample, I think. Let's see if you guys, I'm just going to check in on you once in a while just to see if you have any questions, if you're following along. You need me to go over anything? If you have a super chat with a question. No. Then you don't get your questions answered. You get questions asked, but not answered. No money, no answer. That's how it's worked. With students, which I'll see tomorrow, they've already paid for their university education, so they get answers. But you will have to help me out. Okay, moving on. Yeah, absolutely. Regularity exhibited by events is not a sufficient condition for regularity to constitute a law. For there is more to law or law-like behavior than mere regularity. Amen, right? You can all agree with that. So look at all the difficulties regulators mount up. What they have. So apart from just that issue right there as regularity, that regularity would serve as a sufficient condition for law. Straightforward considerations about laws as they figure into science strongly suggest that regularity is, not a necessary condition either. So now you're in real trouble, regulators. We're just going to call them the regulators from now on. Not only is regularities not a sufficient condition for law, neither is it a necessary condition. Well, what do you mean, Professor? Well, let's look. Remember the distinction between necessary and sufficient. Sufficient is enough to get you this. Having the flu is a sufficient condition for feeling miserable. And that goes, as far as a logical implication, only one way. Because it can't go the other way. That is, feeling miserable doesn't guarantee I have the flu. But it is a necessary condition for having the flu. You can't have the flu and not be feeling miserable. But just because I'm feeling miserable doesn't mean I have the flu. Okay? So now that I've explained that, if the regulators want to have the view that regularities constitute laws, well, it's certainly not it's not enough. It's not a sufficient condition for law-like behavior. So let's see if it's a necessary condition. So if laws describe exceptionless regular connections between events, and if we're going to take that seriously, then guess what? None of the things typically taken in science to be scientific laws would even qualify. See? And let's go over some examples. We already went over an example of Galileo's law of fall. It's spring, it's not autumn, but autumn leaves fall. But they rarely fall in uniform acceleration. Galileo. Where's my Galileo? Yeah. Right under my Einstein. So if where's the proof here? Uniformity of fall. Anyways, I'll look it up later for class, but there is a demonstration here and the two new sciences about the uniformity of fall. If it didn't have brain damage and dementia, I'd be like, oh, it's Proposition 47 right there on page 218. Oh, weird, it is Proposition 47. Okay, so Galileo's law is that objects fall with uniform acceleration. Now, what's the problem? Unqualified, and I say unqualified, regularity view, they'd make the law false. Now we have to add certain things. That's why I said qualifications. But like you're thinking about the Leaning Tower of Pisa and taking two different, I don't know, a bowling ball and another lighter bowling ball. They both fall at the same time with uniform acceleration, but leaves don't. And then you've got to add something to that. Well, there's obviously then exceptions. Let's also take Archimedes' principle, which claims, I'm trying to remember where it's under the computer, I'm not going to pull it out right now. Archimedes has a law, principle that denser objects sink in water, right? Well, that's refuted. with ice, right? And there might be a couple other substances too. If what I'm trying to say is, if laws were exceptionalist regularities, then it's very difficult to find serious candidate for a law for one of all the appropriate regularities. In other words, case in point is that most, if not all, the generalities taken to be laws within science fail to qualify. Okay? So far, so good? So what I'm saying is that autumn leaves don't fall to the ground in regular fashion. Why? Well, there's other factors. The author points out that the influence of even droughts, air resistance, they all act as disturbing factors, such as the sinking of a needle can be exhibited by surface tension. It is because physical processes are hindered by disturbing influences that physical laws characterizing those possessed need to be tested in contrived experimental circumstances. I want you to see this, because this is really important for the argument that we're actually making. It is because physical processes are hindered by disturbing influences that physical laws characterizing those possessed needed to be tested in contrived experimental circumstances. So that all those hindrances, all those other factors, can be eliminated or at least controlled. The regularities of relevance to science, and which are indications of law-like behavior, are typical. The hard-won results, this is it right here. The hard-won results of detailed experimentation, right? That goes for Galileo. That goes for Thomson, Henry Cavendish, Newton, etc. And that's just what he's pointing out, some of these here. We had already went over the failed Hertz experiment and Thomson's ability to actually correct that with the cathode tubes, and the regular deflection of moving electrons within that electric field. I'm not going to hash that back. I'll go back over that. And then we said, laws can be formulated in the form of events of type A are regularly followed or accompanied by events type B, provided disturbing factors are not present. So I put in a conditional form, as long as it is not. Now, why would I do that? Well, suppose I'm a regulator, and I want to defend the regularity view. I add that conditional on there. And so now Galileo's fall becomes, well, the law of fall is heavy objects fall to the ground with uniform acceleration, provided they do not encounter variable resistance or not deflected by winds or other disturbing factors. So you think that you've solved the problem here if you're still wanting to maintain that laws are just simply regularity. But the problem is other disturbing factors. And like a lot of things in philosophy, how precise? There's a general problem concerning how precise statement of the conditions to be satisfied for a law to apply can be formulated. That's one problem. We'll leave that aside for now. And just accept the conditional form. Maybe the regulators with their regularity view of laws can get away with it. So we accept those laws only apply when those conditions are satisfied. That's what you'd be left at. Hear what I said. If we accept the characterization of laws as regularity stated in conditional form, then we must accept that laws only apply when those conditions are satisfied. So your question should be, when are they satisfied? Special experimental setups. Do you see what the problem is here? So nature only obeys laws when I have this special setup. Everywhere else it doesn't. So there's no laws of nature, really. Your law of nature is no law of nature, is basically what the argument is, if you're a regularitist. Good argument. So, it restricts the ability of laws to those experimental situations where the appropriate conditions are met. If you're going to add that conditional, then you're incapable of saying anything about what happens outside of those conditions. That's what I just said. Outside of the lab, and if you even do that correctly, they set up the experiment, nature doesn't obey laws. If that's your answer. Do you see that? That's a powerful argument. Questions so far? Does everybody get what the argument is? Okay. Almost finished with this section. I'll just say a few more things, and then we'll go to possibly another view of what laws can be, because the regularitists are not faring too well. And I'll pop up screen capture. Here's a good point. The difficulty here echoes the problems which arise in the new experimentalism. So, the previous chapter is taken as exhausting what can be said of scientific knowledge. For as we saw in the previous chapter, although it may well be the case that the new experimentalists can catch our strong sense in which the progress of science can be understood as a steady accumulation of experimental knowledge, to leave it at that leaves us with no account of how knowledge arrived at inside the experimental situations can then be transported to outside situations. Brilliant argument here. So even if I grant you that and grant you the conditional, I never get to the outside world, what I'm really trying to inquire. Like, are scientists only concerned with, only care about knowledge in the lab? No, they're trying to figure out something from the lab so they can make some sort of epistemic claim about the world. And if science is trying to study the laws, and if I grant you that, not, ignoring the other problems, I grant you the conditional, then it only happens in the lab. Laws only happen in the lab. I can only say that. So I never get outside. Just like, again, what we saw with the previous chapter here with new experimentals. How do I transport that to outside situations? How are we to explain the engineer's use of physics, the use of radioactive dating, the application of Newton's theory of motion of comets? Scientific laws are assumed to apply outside as well as inside of the experimental situation, and laws cannot be identified with the regularities. Bam. Refuted. Refuted. Regularity view, the laws are dumb. That view has got to go. You see why? Do you now get it? So, we got to look elsewhere. I know scientists should take philosophy of science to graduate. What if I told you that laws are not regularities, but dispositions or powers? Well, this is interesting. In some sense, it's a harkening back. This section is a harkening back to Aristotle. I was just thinking about this book. Real essentialism. Hydromorphism and different things. We'll talk a little bit about that, but let's move on. Shall we? So you could say that, well, things happen in the world of their own accord. Then you're going to have to say, what does that mean? How? Because of what possibly entities are. Their nature. That's why, like, their essences. Now, Chalmers will point out, modernists get scared when you use that word, essences. Teleology, essences. But as one professor of mine pointed out, well, these modern scientists and biologists, they treat teleology like a housefly. They're afraid to be seen in public with her, but Jays, because he was an Irish, so but Jays, she can't live without her. No, it's not raising here. It's 82 degrees. It's crazy. We got snow. It was snowing just like last week, and it's 82 degrees. That's why I'm all sunburned. And sunburn is science. You can thank science because of sunburns. Dang you, science. And I would have got away with it too if it wasn't for your meddling scientists. Alright. Things happen the way that they do because entities in the world possess a capacity or power, disposition, or tendency to act or behave the way they do. So this really is reminiscent of Aristotle. Balls bounce because they're elastic. Maybe Aristotle says because they're ball-like. Warnings that containers that declare the contents to be poisonous or inflammable or explosive tell us what the contents are capable of doing. The audio sounds like it's raining. Oh, it's the air conditioner because it's 82 degrees out. Hi, I'm Father Deacon Ananias, and this air conditioner is brought to you by science. 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 Nobody knows how it works. Something about laws, regularities, and or as we are in this section, it's just because it's the nature of the dang thing to act that way. It reminds me of Joe Dirt finally finds his parents. He's like, why would you leave a little kid? How does the transmission on a Hemi work? Just does, right? We're at that point. It's because it does. That's what those things do. They're capable of doing stuff, exploding, or at least on the the warning label, it says what they're capable of doing. Specifying the mass and charge of an electron indicates how it will respond to the electric and magnetic fields. An important element of what a thing is what it can do, its capacity. And watch this. I told you. We need to characterize things in terms of their potential as well as their actual being, as Aristotle correctly observed. Wham. Just as the ability to grow into an oak tree is an important part of what is to be an acorn, so the capacity to attract, unlike, and repel charges and radiate when accelerating is an important part of what is to be an electron. So now do you see why my professor actually said modern scientists reject teleology, but it's all over their work. I mean, here we have a modern scientist actually saying we need to characterize things, at least he gives a hat tip to Aristotle, but he says we need to characterize things in terms of their potential as well as their actual. And what does he invoke? The ability to grow into an oak tree is an important part of what is being an acorn. Teleology. That's why my professor said, Shinoru, it's like a modern scientist is like a man with his housewife. Always afraid he'd be seen in public with her, but can't, live without her. And by the way, you stole my Lucky Charms. Every Irish professor I had, I always thought, oh, he's going to end with, I don't know what he said this whole lecture, but I guarantee he's going to end with, you stole me Lucky Charms. Okay, let's go back. Let's go back to work. Enough clowning. Okay. So Aristotle had account of that in terms of both actuality and potency, in terms of nature. And we talk about nature in terms of disposition, tendencies, powers. Energeia, right, is the activity. Dunamis is the power, the potency, capacity. So all this stuff is kind of interesting enough going back to that. Despite, by Galileo's time, a rejection and mechanization of nature. So we go on. What's the conclusion? Once we interpret here laws in this way, we need no longer to expect the laws to describe sequences happening in the world, because those happenings will typically be the result of several disposition tendencies acting in conjunction complex ways. Okay. Now somebody asked an interesting question in the chat, and so I just want to go. I don't really. So Finlay Bennett asked, I don't really understand how humans would have any access to regularity if it wasn't just a pattern inherent within things itself. How would we come to know those things? Let's say I don't think regularity is simply a pattern itself. With the regularities. Now we saw the problem with that. However, what we're moving in now is that we're saying laws are more than regularities. Now if you ask the question, how would we know that? Because that's the way the thing is. And what is a thing? Its ability to have certain dispositions and tendencies, they're going to reveal that to you. So the question's kind of answered in the question. And we would see it here. The fact that the tendency of a leaf to fall in accordance with Galileo's law is swamped by the effect. So what we could say is it's the nature, if we were Aristotelians, it's the nature, right? Eventually we'd cash these out in Aristotle's four causes, one of which is the nature, the formal cause. But we have efficient causes too, right? Because we're swamped by the effect of the wind to act on. But I can make a law about the fall in virtue of its nature. Now in more modern terms, we talk about disposition, tendency as a power of the leaf. And so the fact that you can have outside effects, there's no reason in itself to doubt the tendency would continue if that didn't act on that. And then you can even see this in Newton too. Does he bring this up in Newton? No. But going on, we would talk about Newton's law of gravitation describes the power of attraction. Then we can talk about, the irregularities of ocean beds and the attraction of the sun and planets as well as the moon. We cannot hope to arrive at a precise account of the tides from Newton's theory, plus conditions. Let me just see 1 second. What was the previous sentence? The tendencies corresponding to law under investigation need to be separated from other tendencies, other factors. Okay, that makes sense. So that nevertheless gravity is the major cause of the tides, right? So now it seems like we're getting somewhere. So from the point of view of this, that it's either the nature or dispositions of the powers inherent to the matter, or the thing, or the entity. Causes and laws then are intimately linked. Events are caused through the action of particulars that possess the power to act as causes. The gravitational attraction of the moon is the main cause of the tides. Charged particles cause the ionization responsible for the tracks in a cloud chamber, and oscillating charges cause the radio waves emitted from the transmitter. The inverse square law of gravitation describes, and there's Newton's right there, inverse square law, describes quantitatively the power to attract possessed by massive bodies, and the laws of classical electromagnetic theory describe, among other things, the capacity of charged bodies to attract and radiate. It is the energeia, the active powers at work in nature, that makes these laws true when they are true. Now, he thinks, and this is going to go into another great conversation, we have a ready answer to Boyle's question. It's the inherent properties of matter. Now, what I would bring up is, I could get that with Aristotle. Because there's essences, right? And he has, the four causes. Once you abolish essences and mechanize nature, and you become the kind of materialist, it doesn't make much sense to me. It's a cop-out to be like, the inherent properties of matter. That's just the disposition. It's because, as we'll see, it moves the question back. Why should matter have that? What is matter? How does it possess that? If there's no natures. Not to mention the epistemological questions about that. There are serious metaphysical problems with that. I find it funny. Watch this. Here, I'm going to pop this back up. Talking about bad words. Dirty talk and foul language. Here we go. The majority of philosophers seem reluctant to accept an ontology, which includes dispositions of powers, is primitive. Well, probably because the whole history of philosophy, the whole metaphysical part, it's like they've embraced kind of material. Of course they're... And why? Because I said it's going to push the question back further. Now, he says he doesn't understand this reluctance. I don't believe him, because then he explains it. Well, he understands in one sense, and he doesn't in another. Because he says, perhaps the reasons are historical. Well, wait a minute. Powers were given a bad name. Eton vital, right? The vital force, right? The mystical and obscure way they were employed in the magic tradition of the Renaissance. You want to go back to wizardry again? Magic? So that's why they're probably skeptical. I wouldn't bring up Eton vitals and vital forces and primitive powers and stuff like that. But also, here we go, Aristotelians. They don't want to go back to Aristotle. They are alleged to have been exploited by Aristotelians in a cavalier way under the guise of forms. Oh, how dare you say that word. Go wash your mouth out with soap. In this house, we don't believe in forms, right? Isn't that the... You know what I'm talking about, those stupid yard signs. In this house, we believe in science. Science is science. No, love is love. Those stupid... And the rejection of forms. Says Boyle's rejection of active properties in his mechanical philosophy. See there? Here's the mechanism. Can be seen as a reaction, perhaps overreaction to the excess of these traditions. Well, I've always argued that the mechanization within science is a reaction, is an overreaction to Aristotle. Although I wouldn't say I might have some criticisms of Aristotle. I don't know about essentialism itself. It seems to be a possible solution to this. But he says, I guess this is all you have to do to solve a problem. There's nothing mysterious or epistemologically suspect or spooky about invoking powers and tendencies. That's all you have to do. Just reassure in a calming voice. Listen to my voice. There's nothing mysterious or epistemologically suspect or spooky about powers, tendencies, and the like. Say it with me. Powers, tendencies, and the like. Nothing spooky, nothing, no mystery, no spooky. Nothing spooky, nothing. Why? Well, he just says because claims concerning them can be subject to stringent empirical tests. Well, it's one reason why he's probably going to reject forms, but you should still be able to see the effects of dispositional properties, and even in a systematic way. All right, does everybody follow me so far on this? Primitive probably means like fundamental, like or no, of the basic parts, right? So if you boil it down, because in some sense you have this in the modern view that the most real, or the causal powers, because remember we're talking about the direction of causality, they'll say is upward. So from things are determined from the very bottom up to the macro is kind of the idea. So the bottom parts are the primitive. So the powers remain there. Which is interesting because last class we actually got into, switch gears here to talk about this. The cosmological anthropic principle. Because what it seems that there's a problem with all of this is to say the inherent properties of matter. This is what atheists say. The inherent properties of matter, that's what. Well, you're going to need a sufficiently robust metaphysics to explain that. And this kind of mechanism and materialism won't do. Furthermore, we have to think about it in this way. And this is where I presented in class last week the transcendental argument for the existence of God, because I believe that it comes back full circle to what Hobbes, and in fact even his kind of mechanistic is Boyle was, that it's God that's the only thing that can actually explain that. What does he say? I'm going to read it back to you. Laws properly is the word of him that by right, and when in a position to know and do these things, and is omnipotent, hath the power, hath command over others, delivered by the word of God, Hobbes says, that by right commandeth all things. That is properly law. But I don't believe in God. That was the... Well, that opens a theological question. Let's just throw it under the rug for now and try to figure out another way. But you can't ultimately explain this stuff. And as we explained in class, you've got two options. You can't just ignore it. It's either God or it's not God. Obviously, there's either an intelligent personal being that's omnipotent, who's sovereign, who has the right to have command over all things, that purposely and intentionally orders things together such that they're law-like. This is why I would say with the transcendental argument for the existence of God. The non-theistic, revelatory theistic, the atheist position cannot give an account for what? Science, the regularities of nature, i.e. the law, and by regularities, we mean more than what we just saw here, that they are law-like. Correct? Now, people are uncomfortable with that. But think about it. What are my two options? The question is going to go back to that. Sure, I might be able to accept the inherent properties of matter. But I don't know how that's going to be explained in a materialist view. Maybe you need forms. But ultimately it's going to push back the question. Why do they act that way? What are they? How are they? All these further questions. And so you only have two options. Either it's God who has, as Hobbes says, the right. Laws are laws because he has the right. And he has these things correspond, different events and entities be what they are because he created them that way. So I can actually give an account. So you simply saying, well, it's because of the inherent properties of matter. That's why they act that way. That's what a law is. Why are they that way? It just moves the question back. Either you're going to say because they were created that way, intentionally with purpose. Nature's endowed by the Creator with essences in teleology. There's something to, and there's uniformity in nature. There's laws because of the Creator. Or you ultimately going to say that there is no intent, there is no God. If there's no purposeful intention, what's the opposite category? If I hit this camera over on tension and intentionally, the opposite of that is, it's an accident. So if you're not going to go the view of saying, look, I can account for these, I can account for law, I can explain the inherent properties of matter because they have natures that were created that way by God. And he holds that in, as it says, in him we move, as St. Paul says, your own poets say, in him we move, live, and have our being. God sustains that. He holds that together. Right? That you're going, if you say, no, I don't like that, you're going to have to take the other category. Really here is a dichotomy between two things, right? Intentionalism or accidentalism. There isn't an intelligent creator that does these things, this person that does these things on purpose and intentionally, then it's an accident. It's ultimately an accident. Now think about what that means. Everything you have to explain is now, including this entire chapter that we just went over on, what are laws? And why should nature obey laws? You're going to have to say the accidental laws of physics, because an accident. We've gotten questions about epistemology. How are you going to explain that we can know things? Well, you're going to have to say accidental knowledge, accidental morality, accidental science. What does that sound like? It's an oxymoron. Because as we reviewed even in this chapter, these things preclude our common ordinary language. When we analyze that, it already precludes these other notions. That's why he had said with the regularity, we don't have an idea of that it's simply just, there's more to law than simply that. It's not just, and then we got to, well, what if I had a conditional? Then laws of nature are just in the lab, but I can never take them out. It's not like, these things, our ordinary usage of the language already precludes. So let's look at this. Knowledge, I mean, if we just kind of basically, without getting into problems you get here and stuff like that, just take, to be true belief with a justification. Why? Because if I say how many how many jelly beans are in the jar, and you say 57, I say, okay, you give me your belief, happens to be true. And I ask, why did you come to that? And you say, that true belief. And you say, I guessed. I didn't count it, I just guessed. Would we say you know? Well, obviously you know it's 57. No. Why? Because you arrived at a true belief accidentally. And so accidentalism precludes knowledge. Arriving at a true belief by accident precludes knowledge. So if you have to explain how we know things in science or anywhere else in terms of ultimately the denial of God, i.e. accident, you have accidental knowledge, an oxymoron. So you can't account for knowledge. Second, accidental laws. What did we just see in here with the regularity? A set of objections to regularity view of laws involves a claim it does not distinguish between accidental and law-like regularities. Do you see? Even the author knows that law is set against accident. You can't have accidental laws. But if you don't have a precondition to, i.e. God is the intentional creator to explain these things, you have an accident. So you don't explain anything. In fact, it's self-refuting. Why? Because then I can't even say that whatever my position is in the category of accidentalism is true. Why? Because nothing would be truth-oriented. There's no distinction between true or false. If everything's an accident, ultimately, then I'm going to somehow get out of that problem, stand above and transcend and be like, but my theory's true. And I know it. And that's what we talked about last class. As it ultimately does get back to this question of God. We also talked about, too, in terms of accident, something really interesting, and I'm going to pull this up, because there was an objection raised in class. There was a really good objection by one of the students. Well, this is kind of just bias of position. Of course, it looks that way to you. It looks this way to us that the sun is moving around us. But that's just because I think I have a privileged position from the point, or some type of absolute objectivity position from where I'm at. But if I were to switch my position on the sun, it would look different or something like that. And so I just think things look intentional, or that I explain this way. But it's not. What was the example from class when we're talking about, like, why does something behave this way? And you look at the water fills, one of you, the students, had brought up, well, the water fills the hole in the ground. You were like, oh, wow, look how it, did that just for, like, me. So you interpret it anthropically. When, in fact, science is going to say, well, no, there is no purpose, or I think it was, well, look how it filled there, so I avoided the thing like that. And you, the student, had said that as an objection, you interpret it to have purpose, because you interpret it anthropically, but nature is not anthropic. There's no purpose to that. It's ultimately an accident. It's because of prior antecedent kind of causes, et cetera, et cetera. Now, of course, that just moves the question back. Yeah, but why does it act that way? Why does nature? So in one sense, we brought up last class, it doesn't get you out of the problem, too. Second, it actually can't be explained through accident. And remember, I put in that disjunction. Either it's intentionalism, i.e. God, or it's accidentalism. Let's assume for the sake of so I made a reductio. Let's assume for the sake of the argument it's accidentalism. Then I have to say accidental laws of physics, of nature, morality, accidental knowledge, accidental truth, which makes no distinction between what falsehood is. And so then it's self-defeat. It not only is an oxymoron, it's self-defeating, because then I can't actually say that, make any claims about my position actually being true, let alone knowing it. Therefore, by impossibility of the contrary, or a reductio ad absurdum, we know that the only way to actually account, and it moves back, would all these questions that we've been thinking about ultimately do is move back to, because God made it that way. Now, we may not like that, but as philosophers, we're not really concerned about what people like or dislike, but we followed the logic to where it goes, no matter how hard the question is or how uncomfortable. That's what it is to be a philosopher. Okay, moving on, we talked about, in fact, Darwin was, it does look like, for example, everything was created in nature with teleology, with purpose. I'm trying to see if I have my Darwin out. Origin of species. Down. I'm not going to dig. I always feel like I got to share and tell. Just so you know that I've read all of what I'm talking about and I'm not crazy. But I don't have the J. Dyer yellow sticky notes. Because I'm not disabled intellectually and need sticky notes. It's all up here. No, I'm kidding. Jay, I love you. You know it. All right. Darwin, one of many things in the Origin of Species was attempted to do was to give a kind of mechanistic account of why things look like they have teleology. And you get an account, an accidentalism. An accidentalist account. That these things, advantageous traits, are passed on through progeny because they survive. So ultimately it kind of goes back to this question. It's an illegitimate question to ask. It's just the inherent properties of matter. But again, why should they act that way? What we talked about in class, there's a fundamental confusion between two categories. That something is versus why it is. All that Darwin, or an atheist, when he says the inherent properties of matter, or Darwin says that artificial selection, like the way, natural selection, like the way an artificial selection of a breeder would do, nature does by accident, because that happens. That thing survives, and what survives will be passed on, so it's advantageous, blah, 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 you know the story. That doesn't tell me why is it that way. But that it is not a why it is question. So we're still left, why should nature obey laws? Why don't just all undo? In fact, we talked about the cosmological anthropic principle. With Tipler and Barrow's book, if I pop it up here, let's see if you can see it. The Anthropic Cosmological Principle. I'm going to read it so it's super exciting for you, the bio.
Ever since Copernicus, scientists have continually adjusted their view of human nature, moving it further and further from its ancient position at the center of creation. But in recent years, a startling new concept has evolved that places it more firmly than ever in a special position, known as the Anthropic Cosmological Principle. This collection of ideas holds that the existence of intelligent observers determines the fundamental structure of the universe. In its more radical versions, the Anthropic Principle asserts that, quote, intelligent information processing must come into existence in the universe. And once it comes into existence, it will never die out. Well, this wide-ranging and detailed book explores the many ramifications of the Anthropic Cosmological Principle concerning the whole spectrum of human inquiry, from Aristotle to Z. Bonson's, bringing a unique combination of skills and knowledge to the subject. John D. Barrow and Frank J. Tipler, two of the world's leading cosmologists, cover the definition and nature of life, the search for extraterrestrial intelligence, and the interpretation of quantum theory in relation to the existence of observers. This book, the book, will be of vital interest to philosophers, theologians, mathematicians, scientists, and historians, as well as to anyone concerned with the connection between the vastness of the universe of stars and the galaxies and the existence of life within it on a small planet out in the suburbs of the Milky Way. Ladies and gentlemen, without further ado, the cosmological anthropic principle. So, I read this book a long time ago, and what it goes into is basically it's heavily physics and stuff like that. Part of the premise is that it isn't an accident. That almost this kind of fine-tuning argument that if anything was different, right, we wouldn't have us, intelligent life. And that now somebody might want to explain, well, that's because it's an illegitimate question because it just worked out that way. But they go into more details that, no, there's something really interesting about this claim. The fact that we can observe and that things worked out the way that we can observe. I mean, we could be a different place in the Milky Way and not be able to observe certain things, not see anything. Right? That's just one aspect of nature could have, and evolution worked out in many different ways in which we'd be unable to see certain things. And we do know that. Like, there's probably things out there that, we're just incapable of because of our biology or finite limitations of the universe and ourselves are just incapable of knowing about the universe. But who cares? That's not the relevant part about it. The relevant part is, but it's interesting that we're in a position to know the things we do know because we are in that position. And it could have been otherwise. And they're able to kind of show through that it's no coincidence that nature and I don't even think they're theists, right? They were saying that nature's finely tuned for, right, human beings. That the principle going all the way back to the beginning that's guiding it is intelligent life. And this is kind of almost a teleological sense that, like Aristotle said, nature always acts for an end, always or for the most part. So if I ask the question, why does the acorn grow into the oak tree? Because the oak tree, in its full actualization, is guiding the acorn. That's why Aristotle's form is saying that even though you can't see form, the entire plan, the entire actual oak tree, is ontologically in every single part of the acorn. Because it's not going to grow that into that which it came from, Aristotle says, but that which it'll become. I can't get to Disneyland, potentially be going to Disneyland if there's no Disneyland. An acorn can't be an acorn and grow and develop unless there's an oak tree for it to grow into. So it's the end that's guiding. So you see how it's reversed? Science would like to think from the kind of most primitive parts and the earliest stages of, you accepted the evolution story, that, it's just these small things that happened, and the infinite singularity, and then you get into the biological, right, from single cell organisms that develop, and this just happened that way. Not only is that a problem with accidentalism, but even Aristotle had an argument against that too, that
a great argument, actually, that it's impossible to have pure randomness or accident. He has a great argument against accidentalism, to the very meaning of the word. What accident implies prior purpose. So even Aristotle provides a transcendental argument by saying, even behind the word accident, to even use that, you're presupposing, so he's a presuppositionalist in this sense, intention, purpose. And only intelligent beings purposely and intelligently act for ends. Great argument. But going back to this question, so it's not that they're just accidentally happening and then you get these things. That would be the validas question. But that in fact, the reason why these things happened in evolutionary stages, according to Tipler and Barrow, is because of man. Is because the end is guiding the beginning. Just like with the chicken and the egg, the chicken and its full developed form is guiding the egg. If there was no such thing ontologically or metaphysically as chickenness, eggs wouldn't do anything. So why do they act law-like in this way? Because of their nature. Why because of their nature? Not because of accident, as we saw, only because of intention. And what's the intention behind all of this? Man, right? The whole universe, man is, right? In that sense, the Pythagorean dictum's true. Man is the measure of all things in nature, right? Now, ultimately, man, we would say man is made in the image of God, and so it rolls back the question to its foundations in that. But I thought that cosmological anthropic principle was really interesting. Now, talked about alien life, and I remember reading this when I was a lot younger, so I was a kid. And you always hear these things that, well, it's just so self-centered. It's specious to think that we're the only intelligent life in the universe. I mean, the cosmos is so big. So many different combinations in galaxies. It would be statistically impossible that intelligent life didn't evolve and develop somewhere else. Well, Tipler and Barrow take a strong anthropic principle conclusion from the fact that they actually did the work. They're like, let's actually crunch the numbers. And people just have this broad brush, like, well, it's so big, it has to. Oh yeah, well, how big? Let's figure actually what this would actually mean. So, not that you believe this, but suppose the universe is you're giving the opponent or the other person or whatever you're talking to their numbers. How old is the universe? 13.5 billion years old. Okay, so I've got a number there. How big is the universe, right? According to biggest current cosmology. How much matter? How many different galaxies could possibly form or be expected in? How many different combinations, right? What could the different molecules, like all these kinds of numbers, right? And they crunch them to see just on purely accidentalism, evolutionary standard, what would be the bare minimum is the expanse on accidentalism, on a purely accidental evolutionary standpoint. What would be the bare minimum numbers for intelligent life according to those models of science? For intelligent life to arise once, one place in the universe. And what they're able to show is that those are the bare minimum. That doesn't even explain that it guarantees it. That would just be the bare minimum numbers by pure accidentalism, what it would take. And it doesn't even mean that it would occur. It would just be a necessary condition. That means even if you double the amount, or even 10 times the amount of time and space, you would not get double. It's a logarithmic log, so it might be 10 function. Logarithmic function, an exponential, right? Of even if I doubled, tripled, quadrupled the expanse or time of the universe, would not increase the chance that there would be intelligent life. So it ends up being miraculous. And that, again, those numbers would just be on an accidentalist model, the bare minimum. And that blew my mind 20 years ago, that I was like, there are no aliens. Like, on a Darwinian or materialistic or evolutionist point of view, or any cosmology, it is literally impossible in the numbers for there to emerge intelligent life. We actually are special. They go further and saying that it's more than right? It's not just an accident. It's fine-tuned for there to be intelligent life, to even make these discoveries, to write these numbers and books and be able to actually discover these things. It's really a profound scientific thesis. And they even go into, what was really interesting, because you'll notice on here, you have the old cat, Schrödinger's cat, and the experiment, the thought experiment, Schrödinger cat, and the collapse of the wave function. We went over a little bit of this in class, with the radioactive decay, then breaking the poison vial and the you have closed system, the cat's in there. And so the probability is 50-50. Cats either are alive or dead. I mean, it's either alive or dead. Well, what is it? Well, according to Schrödinger cat experiment, and that is developed later in quantum mechanics, it's neither, it's both. Both dead and alive. It's in neither. It's in an inclusive dichotomy and not exclusive, is a good way to put it in terms of logic. Then what happens? It doesn't become exclusively one or the other until the observer opens up and it determines, it collapses the wave function, and then it ends up either you see it's dead or you see it's alive. And then they use that to actually talk about the cosmological and anthropical, about all the things in the universe. That it's the anthropos, right? It's all made from the, the way the bond angles of the, it's all made for the human being. This is really amazing. It's not accidentalism. And obviously these open up theological questions. Do you have any theological questions? Callers are waiting. Callers are waiting, standing by. That was a freebie for you right there. Callers are waiting, standing by with your theological questions. But let's see if you have any questions. If not, I think we can end this stream. Let's see. You guys are awful silent. You're just mind blown. I told you this philosophy science is awesome. Let's see if we got any super chats. Donations. Nobody wants to donate. Let me just check before. Amptown, you're the only one. You're truly the winner of tonight's contest, the only one to donate, and he wasn't even here to... Amtown is the winner. Let's just see in case you guys... Super chat donations can be made here before I log off. So that concludes basically a wonderful conversation about, we didn't get into the laws of thermodynamics. There's some cool stuff too about, if I explained, if I could explain why the inherent properties of matter are the way they are, as I just did, then there's some cool stuff to explain the kind of law-like relations. For example, the famous formula PV equals nRT, and that ice is subjected to pressures higher than normal atmospheric pressure, then its melting point is lowered. Some cool stuff about that. And how to explain why, for example, water doesn't act normally as other solids when frozen. Ice acts different than other solids and water itself. But we can explain that if we say, what's the nature of water? It's inherent properties of, and not just simply liquid or solid. We can explain the things with Maxwell. The laws of mechanics can also be written in a form that takes energy rather than forces as a starting point. In Hamiltonian and formulations of mechanics, where this approach is adopted, what is required is expressions for potential and kinetic energy of systems as functions of whatever coordinates are necessary to fix them. And again, we can couch that all in terms of fundamental laws are due to the natures of that are inherent to the entities and how we explain that. And that's it. So we'll be moving to chapter 15, which will be tomorrow's lecture, realism and anti-realism, and that ends then we're done with, there's some postscripts and stuff like that from the author, but we've actually done it. We've done an amazing job of covering not only just, the history of science, but all the philosophical problems, the philosophy of science itself, the epistemological issues, and the ontological issues, as we'll be ending there. A good introduction to Orthodox theology, well, Meinendorf. It depends on what your reading level is at too. But Byzantine. I'm actually doing a course for seminarians called The Experience of God and the Mystical Theology of Orthodox Church. And it's a combination of kind of various sections of Demetrius Staniloy and Losky and some other stuff that's really cool. But yeah, of course, Byzantine theology, Meinendorf's the ones I'm talking about there. And then also I'll be starting up a catechesis program, in which case I've been going through this book, Orthodox Dogmatic Theology, and I should be starting that up soon. I just have the college, I got to recertify, what's the word I want to use? Double check that I have the room and the recording equipment all set up, and that we're good to go with that. So, other questions? Otherwise, I'm out of here. I'm glad you enjoyed the stream. I'm glad you enjoyed the philosophy of science. Sorry about the audio. It's the air conditioner, brought to you by Science. Finley donates $5. Thank you, Finley. Cheers, Finley. And I want my Lucky Charms. Think about it. Finley sounds like an Irish name. By the way, my subdeacon had to remind me, bring to my attention, that I slip into an Irish accent on certain words in the litanies at liturgy. When for the president of this nation, for all civil and military authorities, he says, "You say authorities," and I'm like, "Oh no, do I?" So now it's like tripping me up. Like every time I'm about ready to say that line from the litany, that I'm like, okay, make sure to say that and say it so the Yanks can understand it. Yeah. What else? Thank you, Finley, so much. Cheers. I don't know exactly what percentage, but it's obviously Norwegian and Irish. And as we all know, you can tell it. I was going to do a Norwegian accent. You can always tell it in Norwegian, but you can't tell them much. And if you tell the grandfather, you can always tell a Norwegian, but you can't tell him much. Wonka, wonka, wonk. Yeah, that's what happens when you grow up in a Norwegian American family. Is you've got all these things, oofta hats and things, classic little things like that. Good. Well, I hope you guys enjoyed. Occasionally I get to do this, provide a free lecture to you, killing two birds with one stone, because my students at Carroll will actually now have this all recorded with audio that we did last week. So I apologize. And we'll be picking up, if you're Carroll College, the final chapter of your life. No, the final chapter of the book on realism and anti-realism. So I'm very excited about that. And then we have, what? Philosophy of Science Jeopardy games. Hope you guys are working on your questions. That's going to be fun. And may the best team win for that. It's always a blast. I put up your finals date. I believe finals is, what did I say, Wednesday the 10th at 8 a.m. I'm sorry, I didn't make the schedule, but there it is. It's in the announcements. And Bob's your uncle. Great stream. Great to see everybody outside of the lab in the real world where the laws of nature work. And here they don't, in my lab experiment room. And wishing you all a good night. And again, I hope you enjoyed. Thank you, Finley, again. Thank you, Amptown. Thank you, students. Keep up the good work. Until I see you tomorrow, God bless.